Hi everyone, my name is Rita Boutros. Today I'll be doing my teaching presentation on teaching fractions to elementary school students, specifically introducing fractions. So before going into the methods we'll be talking about, I just wanted to give some background information on where students stand when it comes to math. So unfortunately, many students view math in a negative way. And they view it as a difficult subject, especially if they struggled with it in the past. And a lot of them may come from backgrounds of discouragements, and they may feel intimidated with learning new math concepts. Because of this, it's really important for teachers to provide maximum support to students when teaching new math concepts, such as fractions, in order to encourage students and push them to succeed. And because there's these views of math being difficult or unattainable, students usually only study math because they're required to. And as soon as they're no longer required to, they stop. And that leads to only a small amount of students that end up having the knowledge needed to pursue careers as those in STEM later on in life. Now, to introduce fractions, you can first introduce the concept of fractions using equal sharing activities. So equal sharing activities can involve everyday examples such as sharing a pizza. Let's say a pizza is cut into 4 slices and it needs to be shared with 2 people. You can discuss with students what's the fair amount way of sharing, and it would be for 2 people. Each person would get 2 slices of pizza. So that's a simple example of equal sharing activities, or you can use any examples in general to demonstrate sharing and introduce fractions. So when we begin teaching fractions, we can use the method of instructional scaffolding. And with instructional scaffolding, you can introduce physical prompts to aid students in learning. Physical prompts can range from items such as beans or tokens that can be used as counters to represent fractions. And we also want to make sure that students recognize that fractions are numbers that expand the number system beyond whole numbers. To teach students that fractions go beyond whole numbers, we can use measurement activities and number lines to help students understand this concept. And once we feel that our students have a good grasp of what fractions are and where they fall in terms of numbers, we can then move on to teaching them how to solve ratio, rate, and proportion problems. And now we're going to move on to how exactly we do that as teachers. So we can teach all of this using different methods of instructional scaffolding. So here's some background knowledge on what instructional scaffolding is. Instructional scaffolding is based on Vygotti's theory of social constructivism. Instructional scaffolding serves as a temporary framework to aid learning and lead to strong learning foundation for the targeted concepts. So aiding learning with this type of scaffolding usually falls into the zone of proximal development. The zone of proximal development is also part of Vygotti's theory, and it's what he calls the area in which students have knowledge of the concept, but they can't yet grasp it all on their own. So they do need that support from an instructor, teacher, or somebody that just knows more than them. And with that support, they're able to succeed in that concept independently after some time. So instructional scaffolding is effective because working with a skilled instructor helps learners connect concepts, and it helps them connect their existing knowledge with the new knowledge. And with this type of method, there's a lot of responsibility placed on the teacher for providing opportunities to making learning possible. So why would we use instructional scaffolding with fractions? Well, like I said earlier, a lot of students can come from backgrounds of being intimidated with math, especially new math concepts. So using this strategy is a great option because it helps to eliminate that intimidation, and it helps to explain concepts in ways that students can understand and relate to, which will lead to successful outcomes. So here we have a photo of different strategies of scaffolding. So visuals, graphic organizers, modeling, so on and so forth. And then also here we have, there's 3 different types of scaffolding. There's sensory, there's interactive, and there's graphic. Instructional scaffolding falls under interactive because it involves teaching with a coach or mentor, like it says here, and it helps students strengthen their skills and engage with the process of learning with an expert. So once students have a good understanding of what fractions are, we can then move on to teaching them ratio, rate, and proportion problems. This is the beginning starting point for solving fraction problems. So we can use the strategy of visual representations to teach this. Number lines, like I said earlier, also serves as a visual representation. So you can use number lines to demonstrate how fractions go beyond whole numbers. And teachers can also incorporate tables like shown here to teach how to solve ratio problems and to just explain ratio problems in general. So here we have a ratio of 1:4 of 1 cup of flour giving 4 servings. So let's say the rest of the table wasn't there yet and we just had 1:4. We know that the next one would be 2 because let's say for 2 cups. And then if it's for each one is 4, then the next on the bottom would be 8, and then the pattern goes on. So this is using tables is very effective, and I've seen it a lot throughout my own educational career with math teachers using this, and it helps students to understand the full picture of ratios and the patterns that are going on with specific problems. So here's another example with tables. So I've seen teachers also use tables like this where students have to fill in the blank. And here we have cards and prices. Students can fill in what they know and fill in the blank. So it would be 3, and then the blank 6, and then the last one 12, and on the bottom it would be 2, 4, 6, 8, 10. The next strategy that also falls into scaffolding is sensory scaffolding. So I think sensory scaffolding is specifically useful to teach ratios to non-English speakers because it involves using real-life objects to demonstrate problem solving. So if we were to use the previous example with the 1 cup of flour to 4 servings ratio, we can do that we can teach that using physical objects to demonstrate the problem. So we would need to use a physical object to demonstrate cups and a physical object to demonstrate servings. So an easy way to do this would be using plastic cups to demonstrate cups of flour, which is very self-explanatory and will help English learners make sense of what's going on. And we can also use classmates. As if we're doing a whole class activity, we can use classmates to hold like the cup of flour. So it would be like a group of 4 having 1 cup and demonstrating it that way. But other than that, you can also use desks as a representation for servings. So for 4 desks, there would be 1 cup. And we can do this. We can also allow students to participate with this process by being able to place the cups and answering questions of where would we put the next cup, or how many more desks are for the next cup, and so on and so forth. To further help in understanding the ratio problem, the teacher can narrate along demonstrating the example with real-life objects. Next, we can also use auditory scaffolding. So auditory scaffolding involves the teacher talking and following along and instructing students with the steps needed to solve the problem. So here we have an example. If Steve can purchase 3 baseball cards for $2, how many baseball cards can he purchase with 10? So as a way for the teacher to aid the student, you can state the steps needed. So first you're going to tell your student, okay, step 1, identify the information given. Student should be able to identify 3 baseball cards that cost $2. That's what's given. And then Stephen wants to purchase cards with $10. And then what do we need to solve for? Okay, how many cards can he buy with $10? Can be bought with $10? And then what strategy can we use to solve this problem? Example, table. And step 4, what is the answer? So you can walk your student through this by narrating as they are trying to solve it and help them do so. So you're speaking to them and they're writing down. So this way it helps them to be active in their learning as well as be guided to the right direction. So as a teacher, you can repeatedly use the strategy of auditory scaffolding until you feel like the student has learned to solve independently. So auditory scaffolding is specifically useful to guide students with learning disabilities. Reason for this is because teacher-directed instruction is the primary way to teach math to students with learning disabilities. And to guide students with learning disabilities, teachers can narrate the process of solving ratio problems. So with narrating, you can go as fast or as slow as you need for your students. So maybe for a student with learning disabilities, it takes a couple minutes to just go through the first step. That's fine. You can cater to your student as much as they need and for their specific needs. And the last strategy that I'll be discussing, this can be applied to students with disabilities or students without, and it's to guide students in monitoring and reflecting on the problem-solving process. So as students are learning, we want to make sure that they're engaged with their learning and that they're building on with their learning. So you can provide students with a list of prompts to monitor how they're doing. So that involves asking students questions or provide them the questions for them to ask themselves if they're working independently. So example questions are, okay, what is the story in this problem? What is the problem asking? What do I know about the problem so far? And what information is given to me? How can this help me? So this strategy was found to be highly effective for students in learning and in developing their own independent way for solving. And here, the example questions are similar to the steps here of identifying the information and helping students each step of the way, except here where they're kind of doing it by themselves. They're connecting their own knowledge and what they're learning kind of on their own. And throughout everything, we want to always encourage independent learning. So once you feel like you set a good foundation for the basic grasp on fractions, you can now provide learning experiences that are within the student zone of proximal development. So like I said earlier, it's when this is the zone where students can do things on their own, but they might still need help. So you can help them as needed, but the goal is to provide the learners with the guidance needed in order for them to be successful on their own. And that's all for my presentation. Here are the references mentioned, and thank you so much for tuning in.